Yeah, so tomorrow. Yeah. No. One of the advantages you had a strong team. Yeah.
Okay, good evening, everyone, and welcome to Burlington House, the Geological Society, our home here on Piccadilly. So it's wonderful to see so many of you here in the room, and thank you also to our online audience. We had about 200 people registered for today online, so we're expecting this to be a really, really busy one. For those of you in the room, some brief housekeeping. We are not expecting a fire drill this evening, so if you hear the alarm, please treat it as a real event. You've got multiple fire exits, and I'll do my best flight attendant impression. 3 at the back of the room with the green lights above, and 1 here at the front as well. And you can follow the JOLSOC members of staff who are all wearing lanyards out into the courtyard. The assembly point is in front of the Royal Astronomical Society. Hopefully we won't have any issues though, but just so you know, in the event of hearing anything untoward. So thank you for coming tonight for our May public lecture. We're delighted to be able to host Professor Ian Stewart, who will be known to many of you. Ian is a very big name in the geosciences, I think it would be fair to say, over many years. Multiple degrees, not just an undergraduate from Strathclyde and a PhD from Bristol, but 3 honorary PhDs as well, which I think might be a record, at least in people that I know. Initially working after graduating at the West London Institute of Higher Education, which then merged with Brunel, and later at the University of Plymouth, where you became the first professor of geoscience communication, we think, anywhere in the world. So a really, really important topic. Ian also then later became the founding director of the Sustainable Earth Institute at the University of Plymouth, further cementing the reputation of the importance of geoscience communication, not just for human populations, but the sustainability of our planet long term. He also holds a UNESCO chair in geoscience communication since 2018, and in 2021 took a 4-year secondment in Jordan as the Al Hassan bin Talal Chair in Sustainability, and that has just finished and he's returned to the UK. So we're very lucky to have him here today. Of course, that academic career is not what many of you may know him from. He spent 15 years working with BBC Science on a huge range of different science documentaries, which culminated after 15 years with sitting in a bathtub full of oil, twice on Planet Oil. And for all of those activities, both academic and for services to broadcasting, he was awarded an MBE from the Queen in 2013. Ian's been an honorary fellow of the Society here since 2010, and last year was awarded our prestigious Koch Medal for services to geoscience communication and the community as a whole. So we're very, very lucky to have him here today. I'd like to introduce Professor Ian Stewart onto the stage as a wonderful geoscientist, a fantastic communicator, and a very, very well appreciated colleague and friend. So Ian, over to you.
Thank you. Thank you. Yeah, so I'm supposed to be famous, but I asked ChatGPT last week to draw a cartoon of the Scottish geologist and BBC broadcaster Ian Stewart, and this is what happened. And it got the nose right, and then I was a little bit confused, and it suddenly dawned on me, it's mixed me up with Neil Oliver, I think, the Scottish archaeologist and BBC presenter. So it doesn't matter, wherever we go, geologists are getting mixed up with archaeologists time and time again. So what I'd like to talk about, in a way, relates to that, which is why is it that geoscience has such a low familiarity with the public? Now, that's always been just something that's in the background, but it's something I think that's come more to the fore in the last few years, and there's lots of reasons for it. In terms of, with the university sector and in the industry and a whole bunch of reasons. And so my point really is going to be that I think we need to re-embrace our skill that we intuitively have as storytellers. And I think I'll try to convince you of that, take you through that. So I'll start with this slide, because this is a slide that really tries to explain to the public what it is that a geologist or a geoscientist does. And you'll recognize a busy slide, lots and lots of different things. But my question really about that slide is, what's the narrative? What's the story that it's trying to portray? One of the things is just how broad geoscience, geology, earth science, whatever we're going to call it, is. But that's part of the problem, really, because actually, apart from the fact that it's very busy and complicated, and so it doesn't have a kind of simple narrative, actually it clashes with quite a lot of other subjects. So geographers do a lot of that stuff, engineers, civil engineers do a lot of that stuff, biologists probably do a lot of that stuff. The area that's probably most ours as geoscientists kind of tucked down in the bottom here. It's the subsurface realm. It's kind of rather embarrassingly put to the side. But I'm actually going to talk in the end. I'm going to come all the way around to something that's not even on there, which I think is really important. But I'll save that for later on. But my main point is that we need some clear narratives to guide us through how we, and I'll use this word deliberately, sell geology to the wider public. So some of the big things is we think of ourselves as the scientists of planet Earth. And planet Earth is really interesting to people. So these are that image at the top left shows all of the atmosphere, the breathable atmosphere that we rely on. There it is, tucked up there. That's all we've got. And if we mess up that little pocket of gas, we're in big trouble. Below that, so all the water we have on the planet hanging like a water droplet about. These are big issues, big planetary scale issues. And then this one here looks at the fundamental tipping points in the Earth system that geologists have unpicked really through the geological record, but this is where they are now. And the top right diagram is one you'll be very familiar with. It's the UN Sustainable Development Goals 2015 to 2030. And these are ubiquitous now. You go onto any university webpage and you'll find the academic staff, and attached them will be the UN goals that they work to, and they're everywhere. But what's not in there really is geology and earth science. I mean, you can squeeze it into a few of them. You could certainly squeeze it into industry, innovation, infrastructure, decent economic growth, energy at a time, but it's clean energy, so it's solar and wind. There's a bit on sustainable cities around engineering and hazards. But the point is that you have to struggle to find places to put this subject. And yet, this is a subject that deals with the planet as an integrated, holistic system. So how is it that the science that's actually looked at that whole planet has kind of fallen through the cracks, really, when putting together things like the SDGs? And that's just the goals. If you look at the 151 targets that sit underneath those, very few of them relate to geology. So when someone says, oh, I do SDG 11, generally they don't, because they're not addressing the targets in SDG 11. They just have the overall theme and say, oh, I work on this. So it's interesting going back because in the run-up to the establishment of the SDGs, there was a real push to try and get earth science into it in a big way. So one of the questions, the top left really thinks about the way that we portray the Earth system. And in that one, you can see the economy was seen as a small part of society, and society was embedded in the Earth system. So the Earth system was fundamental to this thing. And one of the interesting things was before the SDGs was the Millennium Development Goals. So that was a 6 goals, mainly development goals in terms of poverty and health and things like that, but there was an environmental one. And that was the predecessor that was going to run into the SDGs. But in the meantime, the science had been started to develop around planetary boundaries, planetary tipping points. This big scale stuff was happening. And so, for example, this paper here was suggesting, like, what we need to do is take the Millennium Goals, merge it with this new things about the planetary scale problem. So materials, you'll see there, clean air, nutrients, hydrological cycle, et cetera, to create this new set of goals where would be fundamentally underpinned by earth science. In fact, the redefinition of the Brundtland definition of sustainability gets tweaked to be the development that meets the needs of the present while safeguarding Earth's life support system on which the welfare of current and future generations depends. That bit about Earth's life support system was the geoscience contribution to try to put the SDGs. But none of that made it in. And instead we get that kind of checkerboard list of things. It's someone said to us, it's not about science, it's about politics. So that's the thing, because it's functional, it's useful. You can set up policy documents, you can tick checklist things against it. But what it doesn't do is show the interconnectedness that sits underneath the whole system. So this is the planetary boundaries idea. So this was by particularly the Stockholm Resilience Centre set this up. 2009. So this was, they said, the first two really before the SDGs came in, with the idea that there are fundamental boundaries that, if crossed, have huge impacts for humanity. And yet you can't find those in the SDGs. And that's really interesting that we can tackle them. We might be able to tick off a few of those SDG targets. But what if one of those boundaries gets crossed? That's not really apparent in the SDGs as they're conventionally portrayed. So what we see as we chat them through is actually, it looks like we're crossing more and more of those planetary boundaries. Now, interestingly enough, Kate Raworth, who has done the donut economics, actually inserted in the middle. So that's the idea of an ecological ceiling. If we go past this ecological ceiling, we're in trouble, because we know this from our baselines from the past. But what she did was she brought in a social foundation, a basement, saying if we go, and this was about housing and poverty and health and inequality and inclusion and things like that. If we drop below that, we're in trouble. And he ended up with this, what was in between was this kind of like a life belt, which was the safe and just operating space for humanity, limited by an ecological ceiling that we see here and a social kind of basement. So that was planetary scale science getting used by social science. And Kate Raworth was at Oxfam. She was the research director at Oxfam, looking at how we could bring the planet well-being and the human well-being elements together. So going back to the SDGs, this was an attempt. I mean, I think lots of people have recognized the lack of a narrative, an engaging, compelling, motivating narrative in the SDGs. And this was a way of trying to do that, whereby, for example, some of the SDGs you can see at the bottom there, they're the resource base. They're the fundamental foundations of everything else that's on top of that. And then essentially there's the economy on top of that, then sustainable production, consumption, etc. And then there's the human dimension, if you like, fundamental human dimension at the top in terms of poverty and human well-being. So that kind of pyramid, and it really comes from an idea by a guy called Herman Daly, who was a World Bank senior economist in the 1970s, who came up with what became known as Daly's triangle. And this is more or less it here. And what this shows really is the fact that what Daly said was, look, everything relies on what do you call the ultimate means. It's the biosphere, it's the solar, the sun, it's air we breathe, water. If we don't have that, everything else bets are off. He says, but what we do, of course, is we have to transform some of those raw resources into stuff. So we have this built in human capital. So we have factories, and we have processed materials, we have jobs, we have create these things. And then that gets changed into creating the systems that we rely on. But one of those systems is the financial system, because this is the economy. So we're driving economic growth to generate stuff. And his point was that people see the economy and making money and financial maximization, profit maximization as the point of the economy, as the end result. And he says that's not it at all. The economy is a means to an end for the betterment of the human condition. I mean, that goes back to the Enlightenment that starts geology off in the first place. So he says, look, they're just intermediate. The ultimate end is long-term well-being for humanity and for all life on the planet. That's what we're doing. The reason that you have a salary, you get a salary, is not because you can look at your bank account in your form or in the web. It's just to use that money for doing something good that makes you feel good. So this is all about social inclusion and community and identity and all of these things. It's hard to pin down. So anyway, so these are both saying the same thing. We rest on the ultimate means, and we go through the economy, and then we get to essentially the human well-being, or what's referred to as well-being economy, which is there's 5 or 6 countries in the world now that's put well-being as one of its metrics of what makes a successful country. It's not just GDP. So Scotland, Finland, Wales, Canada, New Zealand, Iceland have got this thing about well-being. Human well-being is the ultimate test of an economy, of a country. So that's the kind of context then that we're kind of working in. And what I would argue really is that geology has been tucked in to this bit, into this bit quite well. But what about the top bit? So getting back to the point of the thing, I think geologists are natural storytellers. That map over there, you can't see it, it's around the corner. Sorry, if you're looking here, that map over there, a geologist to explain that will tell you the story. They'll usually start at the oldest rocks and they work through it. You know, if we used to batter that into the students, why have you started with the young? You have to start with the young. You tell the story. So time runs through geology. So we're constantly talking about a story of the Earth. So we're the storyteller for the planet. Certainly for the past, and probably for the future, and you'll see geology departments around the country, around the world, trying to adjust to this notion that we're actually trying to say something about what's happening now. For the future, I think we are for the future as well, but that's harder still about thinking about, to what extent the past is a guide to the future. But the point is we're storytellers. And I think that one of the key messages is that idea that we need to kind of rediscover that a little bit and embrace it. So about how many years ago? 10 years ago, they put me in a box in the Eden Centre. You can just see up, if you've been to the Eden Centre, there's the domes. For 40 hours, they put me in a sealed, airtight box, and they took the oxygen levels down to 12%, from 21 to 12%, so just on the edge of hypoxia. And they stuffed in there a whole load of plants. And the idea is it was the Priestley's bell jar experiment, which some of you may remember. So no, not because you were there, because it was like, I don't know, 1800s or something like that. But you might remember it from. So Joseph Priestley put a mouse in a bell jar and he watched it die, because you could do these things before ethics, and he watched it die. And then he then put a mouse in a bell jar with a plant, and it still died, but it took longer to die. And he thought, oh, there must be something in there. And eventually it ended up him discovering oxygen and the role of plants in producing oxygen. So I was the mouse, and the idea was, could Ian survive? Because I was obviously going to use up the precious oxygen that was left in there, but the plants were going to take my carbon dioxide and put it back out. I won't do a spoiler alert to find out if I lived or not, but the point was, what's interesting about this is that's the basics of photosynthesis. We could have just said it. We could have done a little diagram. We could have done a visual things. There's something about living it, and then the story of you experiencing something is really, really powerful. And in particular there, because that shows me really strongly exactly how much of the biosphere I need just to stay alive. I mean, literally, you can see the hammock there. I did nothing. So just to stay alive, I needed all those kind of plants. And so there are ways that we can start to really try and connect with people in different kind of ways. But the real reason I'm telling you about the Eden Project is because they're amazing. I'm sure some of you have been there. What I really liked, that was my first proper experience with the Eden Project. What I really liked about them is storytelling pervades the whole system. What I hadn't appreciated was if you go into, so these are, this is a tropical biome and this is a temperate biome. So if you go into one of these, it doesn't matter which one, they have a storytelling way of taking you around. So what you encounter first if you walk into this tropical one is reconnect. So the idea is you've been disconnected from nature. So the first thing you need to be reconnected with nature. So the first little bit is easing you into the fact that nature's important in your life. They then have awe and wonder. The next set of things is like, that's amazing, an amazing plant, spectacular, or a plant doing something spectacular. It just makes you think, it's a jaw drop thing. And then you go a little bit further, and you go, there's a problem. Deforestation or a disease, and it's all very sad, and you see images of bad things happening to the biosphere. And then you go on a little bit further around, and then good, it's a hope thing, good practices, some examples of people trying to make a difference somewhere in the world. And then finally, you come around to the last little bit, if it's in the tropical one, it's just here, and it's examples of this is what you can do. You can do it as a consumer, for example, by buying certain products, or you can do it as you can invest in this or this process, or there's something you would to avoid doing in your personal behavior. The point is you leave invigorated by the whole experience and feeling good about the process. And that mode of storytelling, that arc, is really important. So if we were thinking of that in terms of geoscience, the first bit is reconnect. And since we're in the JOLSOT, I have to acknowledge the words of Ted Neild. So I wrote a paper with Ted a good few years ago now, and this is his words. So it's a fact often overlooked by scientists that most other people are mostly interested in other people, and they're mostly not interested in anything else. The fact that scientists are more interested on average in things and ideas marks me out as mentally unusual. People are interested in people, and we're interested in all this other stuff. So I put this reconnect stroke connect because I think part of the business is, as a scientist, we struggle to, first of all, just connect to normal people because we're interested in things and ideas, and other people are interested in people. But of course, the other way about the fundamental need to connect is people aren't that familiar with our world of geoscience, of geology, etc. So that, and really, this is part of the problem is the way that we train ourselves as scientists, because this is the way we train in the green here, where as we start, you go to university, and in first year you learn loads and loads of stuff, and in second year you learn, it suggests you learn less, but I guess you get more focused. You then start doing research, maybe a master's, maybe a PhD, and you get narrower and narrower and narrower and narrower. And finally, you get something, maybe it's your first paper or report, and you want to communicate it. And you're down there on that little tip. But the public or the policymaker is there, that sharp point there. So that when you start to say, why are you talking to me? What's this all about? What is relevant that you've got to say to me? And so if you can't make that connection in there, there's no such thing as communication. It just goes past. But if you can find a way of connecting in, then you can draw people more and more into the detail until finally, maybe you're saying, that's a really good question, Max. That's something we really don't understand, and suddenly you're in the detail. And I think for me, stories is the way to make that jump across. One of the ways that we often do it, and I've got the obligatory phone here to just do that, is to say, why is it that people don't know what's in this mobile phone? There's lots and lots of really important critical minerals and rare earths and all that's in this phone. And I tried this on my kids, and I know the answer because they don't care. They don't care what's in the phone. I don't actually care what's in my phone. There's loads of minerals and elements. I'm sure I never got an undergraduate in there. But what about a toaster? That toaster, you can get down in Argos for £16. I bought a toaster. You can get that toaster for 16 quid. It's probably the simplest piece of equipment in a house, in a kitchen. But what's it made of? And where does it come from? Well, a few years ago, a Royal College of Art student, for his final year student, decided to make a toaster from scratch. And he took that toaster and he unpacked it. And he found out it had 141 components in that toaster. But it fell mainly into, there was plastic for the coating. There was some iron. There was some copper for the wires. There was some nickel. And there was some mica for the heat retardant sheets. So he set about trying to go and get the raw materials and transform it into a toaster. So for the iron, he went off and he went to I think it was a New Forest, or maybe it was a Forest of Dean, tried to get some iron from old iron workings and tried to smelt it in his backyard. That was a real tricky thing. For the plastic, he actually emails, he's got the whole transcript, and I've emailed BP and said, can I come to one of your platforms and get the oil in order to make the plastic? And there's a wonderful transcript of this guy, people going, I don't really think we can do that. And anyway, you're not allowed on a helicopter. I mean, we'd never have oil in a helicopter. So in the end, he got some oil from his backyard or something like that. I mean, cooking oil or something like that. He got a little bit easier with the copper. The mica, he went all the way up to the Northwest Highlands. And him and his mate, tramping up a mountain, completely unprepared. They didn't have a jacket. And they were trainers and had a jacket. And just as the cloud was descending and they were getting really serious, they found what they looked for. There was sheets of mica, and they get it and they took it back. Anyway, what was the end result? This. He spent £1,600 and he made a machine that made bread ever so warm. And his conclusion is quite interesting. He says, it's absolutely ridiculous that, I wouldn't even call it a toaster, this bread warmer, costs £1,600. But it's also ridiculous it costs £16, because it's not factored in. All of that stuff that people just accept, they just don't know where it comes from. None of that gets costed. None of that gets. So people don't know where anything really comes from. And I think that's partly been our problem and our fault. And I think these kind of things are the ways that we need to try to connect in. But we have to connect with things that people are interested in. And I can tell you that my kids are not interested in a mobile phone. So that's the next thing, awe and wonder. Well, this is the easy one. We have loads of examples of awe and wonder in the geoscience world. It happens to be the most amazing place I've been. I think it's the Playa de Lunes up in Bolivia in the Altiplano, where we have this beautiful sheen of kind of water of salts that are washed down from those mountains there, and then they form this kind of big salt flats. But we've got volcanoes, we've got earthquakes, we've got dinosaurs, we've got landscapes just generally. We're not short of things that just make your jaw drop. But that same place has got jeopardy. So this notion of the problem, that is home, those salt flats are home to 1/3 of the planet's lithium reserves. And as we move into that, there's renewable energy, and we need lots of things for the decarbonization and the electrification from low carbon solutions. One of the big questions will be, what do we do with this place? Do we dig this up to get the lithium that we need? So that's a moral ethical question. It's not a technical one, it's quite easy to do. It's much more of a moral ethical question about the role that we have. And it's a really important one. And we're going to face this again and again and again. Someone said to me, any future that's got a lot less carbon in it has got a lot more mining in it. We need more stuff to drive this. And yet that's unpalatable in many places. So there's a yin and a yang between these amazing resources we have on the planet and actually the exploitation of those resources. And then this notion of hope, where we bring it in. I love this idea of the green stone age that Morten Smelner of the Norwegian Geological Society produced in this book, the Geoscience publication, talking about this new enlightenment that's going to be creating all these new materials that we're going to, that geoscientists will at some point have to go out and supply. That's what we do. And so this is a kind of brave new world of material science that we're just on the cusp of. So there's that notion that we can really help in the planet. And again, this is one of my favorite stories. That's David Stevenson's a planetary geophysicist at Caltech, and years ago now he produced a modest proposal to send a probe down to the center of the Earth. It was quite feasible. He said, we just need to go to the San Andreas Fault. We need to set off a nuclear explosion on the San Andreas Fault. We need to pour molten iron into it, which will then, due to density, move down. We need to put a probe into it, and that probe will go to the center of the Earth. And he said, of course, that's completely ridiculous. But the sheer challenge of trying to do this will actually drive lots and lots of innovation. And why is it that we're so fascinated by sending probes up to the distant points of space, when actually the stuff that's underneath us is crammed with interesting stuff, much of it unknown, even though it's very close to us? So why is it that we are fixated with the night sky about all the stuff that's up there, but not really that concerned about the stuff that's just tens, hundreds of meters beneath our feet? So I think this notion of capturing some of these bigger stories is really quite important. And then the last one is about agency. And really that's about making people feel empowered to actually do something. And this photograph is from Wadi Rum. It's the last 4 years been based in Jordan. And this is Kenta, my friend Kenta, who's a geologist, who's explained to this local Bedouin person about the science narratives of what this is. It's a set of sand river deposits, basically. Now, of course, he has huge, a Bedouin colleague has got lots of stories about narratives about that landscape and how it was created. They're not the same as ours, but they're interesting all the same. But trying to make that connection with people about their landscape, their world, their heritage, and then what that means for them to empower them to be able to think about the ways that they want to exploit it. So he's very interested, for example, in trying to understand about the geology so that they can talk to the tour. He runs some of the tourist camps in Wadi Rum and be able to explain it. So this idea of empowering people, I think, is the other aspect, which I'll come back to. But this idea of stories is now kind of spilled out into lots of other ways. There's a climate storyline. So this is a paper by two climate physicists. So they're climate modelers, running these huge kind of models, complicated models. And one of the points is that climate models run pretty well globally, not bad regionally, but as soon as you try and take it to the local, they're all over the place. The error bars are huge, and you can't really say very much. And so what this is really saying is that we need to flip the situation so that the climate physics explains what's going on in a storyline approach, so that the local community can say what they think might happen. So for example, this is our storyline. So you have the climate sensitivity and climate forcing. Those are the physical parameters that you put into climate models. And that can produce, for example, global warming. But global warming, there's these kind of planetary scale things, but there's also regional effects. So there's local effects depending on topography, so dynamic conditions, that produces a hazard. And then this then goes into an impact on the ground, but alongside that impact will be the natural vulnerability, etc. So you can say, as a result of these climate models, we think it's going to get warmer and it's going to get wetter. What does that mean to you? And so a local population, local community can say, well, if it's going to get warmer and wetter than this, and they say, yeah, okay. So some of the climate models said it will get warmer but drier. There was about 10% of them. Oh, well, if it's get warmer, drier, then we won't be able to use this crop. So what they can do is the uncertainty, the variability in the climate model starts to get drawn into a storyline approach by which people can actually start to make much more clear decisions on the ground about what a drier or a wetter climate would mean for them, rather than trying to explain the climate models, which are kind of complete black boxes for most of us. And I think this is the point of this, is taking uncertainty. Things that are inherently uncertain. We deal with this all the time, whether it's geohazards or whether it's climate, fundamentally uncertain. And we end up doing probabilities we say there's a 66% chance of this. And then we get upset when the public don't understand that. What is that? I mean, who knows 66% of it? So this is not about probability, it's about plausibility. What's possible, and then creating a story out of it and getting people to react to the story of that. So anyway, the main take home for that section really is that we get fixated by facts. And facts are important, but they're not very interesting usually. And actually, what's much more interesting is a story. And a story has to have facts to make it sensible. It's got to have an exoskeleton of facts. And because people remember the story, they generally remember most of the facts. But we seem to be stuck in this idea that our job as scientists is to tell people things, tell people this or that, and then get upset when they immediately forget it. This paper is by Somerville and Hassel, is in Physics Today by 2 climate scientists. I love it. Try to craft messages that are not only simple but memorable, and repeat them often. Make more effective use of imagery, metaphor, and narrative. And then the key thing, in short, be a better storyteller, lead with what you know, and let your passion show. These are fundamental ingredients for a scientist, I think, generally. But we don't really tell students that's important, letting the passion show, for example. But it's fundamental. It's certainly fundamental for a communicator. And I think that one of the things is allowing us to bring out some of these elements in our kind of scientists. So my point is we need to learn to tell stories better, or reconnect, if you like, with the ability to tell stories. So in this bookstore, it could be any bookstore. I was over in Waterstones earlier on. It could be Waterstones if you wanted. Imagine you go in and you say, I'd like a book on geology, please. Where would it be? First of all, the person at the till will probably say, what? But let's get past that. Where will the geology book be?
In the warehouse.
If it's not in the warehouse, where would it be? It will be non-fiction, so yeah. So let's say the right side is all non-fiction and the left side is fiction. Where will it, so it's going on the right side, where will it be? At the back, probably at the bottom, alongside New Age crystal thinking or...
Dinosaur section.
Well, there might be, chances are it will be, if it would be a dinosaur, it would be a volcano book or something like that. But what's interesting is, what is on that right-hand side? What is there with large sections? What can you imagine that bookstore is full of in terms of the sections? We could all go across the Waterstones and check if you want. Or we could travel, history.
Fiction and stories.
Hmm?
Fiction and stories.
Well, fiction and stories on that left side. We're going to come to that. But yeah, on the right-hand side, the faction, if you like. What's Cooking? Yeah, so travel, cooking, biography, music, the things that normal people like. That is the headspace of the public. And it's really important because that's where they go and spend money, isn't it? They walk in, they'll spend money. And the fact that there's not a big section on geology tells us not that they don't like geology. It's just a small part of their world. They don't need a big fix of this stuff. And this is one of the problems. We, in this hallowed ground, geology is a much bigger part of our personal world than it is for normal people. So when I did my first television series, my series producer, I met her, we arranged to meet upstairs in the library in the little coffee room at the back. And I had got it commissioned. It was all going ahead, and she was allocated to me as a producer. And the first thing she said was, can I be honest? It's kind of boring. And I was like, oh, this is going to be really bad. And I said, what do you mean? And I think I'd called it The Men on a Plate. It was going to be going around, we're going to start around the plate boundary, we're going to go up the biblical holy lands and tell those amazing stories, going to circle on the North Anatolian, tell stories of the Turkish empires. Then it was going to be Greece, talk about Greece, then it was going to be hopping across to Italy, going down, talking about the Romans and volcanoes, going into North Africa, finishing the Straits of Gibraltar. It was brilliant. It was a brilliant premise. And she said, every week, earthquakes and volcanoes and tsunamis killing people. And I was like, I do a whole 10-week course on this, and my students really like it. She said, if geology seems to me interesting, I don't know much about it, she says, but it seems to me much more important to people than just killing people. Okay? So she changed that whole first year, the hot rocks, Johnny's from the centre here, some of you may remember. Architecture, water, food, belief, and art, because art was the chemistry of the periodic table. So we reshaped geology through these lenses of the bookstore. But that's not the bit I want to talk about. I want to talk about the other side. Half of that bookstore is fiction, stories, which tells you people like stories. And it's that bit that I think we need to kind of grab hold of. So one of the things is that we actually do tell stories. This is the paper Jonathan Phillips, the geomorphologist, put a few years ago now, talking about that we have plots, narrative plots, that are just kind of boring ones. But we do structure our science in particular ways. And his quote there about, what we need to do is just re-engage with this fact that we're already setting things out as a narrative. We just need to be clearer with what we're doing. Now, the science of this is pretty clear. This is a review paper in Proceedings of the National Academy of Science, arguing that narratives offer increased comprehension, interest, and engagement, particularly for complex subjects. In other words, the more complicated the topic, the more a narrative structure helps people find their way through it. Second reason why it's important is that the non-experts, whether that's the public or a journalist or something like that, they frame the ways of communicating in stories. So even if we're not going to do it, the way we engage with them, we need to be thinking of stories in order to connect with that. In fact, what they say at the end is they say, in fact, narratives are so important, so persuasive that we need to be very careful how we use them. We can all think of examples of people who have amazing stories, but are talking absolute rubbish, and that people are buying into it, et cetera, et cetera. So this idea that narratives work, stories work, and it's just another tool that the geoscientists can take on amongst the many other tools that we do. So Aristotle had beginning, middle, and an end, and 2,000 years ago, before. And Freytag, by the end of the 18th century, had this Freytag's pyramid, where he says this was him analyzing European myths and saying, look, the basic thing starts, most stories, with an exposition, setting out the context. And then there's an inciting incident, something that kicks off the whole thing. And then there's a piece of rising action where the protagonist, the hero, is reacting to things that are coming at him in a kind of, complicated way. And then the hero, in that process, that protagonist gets changed, transformed in some way. And then there's another set of adventures and journeys, the falling action in this transformed state, until there's some kind of resolution event, and then the whole thing gets ended and wrapped up. 100 years on, there's various versions of this, but there's a guy called Robert McKee. It's 3-act structure. So again, setup, confrontation, resolution. It's got some of the same things, inciting incidents, but there tends to be these are points of dramatic kind of tension in the stars here. Critically, you get this rising thing, and then there's a false climax at the end of Act 2, where you think you're getting towards the end, and then suddenly it's changed, and the last act, the resolution, is this fast-paced thing going to turn to close it all. Now, Robert McKee was famous because he would give these 2-3-day seminars, workshops. He would come across he's a screenwriting professor in University of California. But he would give these workshops for wannabe Hollywood story writers. And he would, show movies for like 3 days, just unpacking them and talking about how they were constructed. BBC Science used to send most of their science producers. When I was working there, the late 90s and early 2000s, most of the science producers went on that Hollywood script writing course and came back and wrote the scripts in that kind of style. In fact, BBC Horizon underpinned BBC Horizon for 2 decades, that model. Sometimes good and sometimes bad. I mean, if you want to see a great example, Fermat's Last Theorem, which is the only BBC Horizon to win a BAFTA, is a perfect example of McKee's 3-act structure. But anyway, the point is there is a form to these things, and it's a case of learning it. And I think that we can take it a little bit further, because I think if you look at Freytag's triangle, and then you look at the classic ways that some kind of dramatic story is put together, you've got the Act 1, which is setting up the characters and setting up the theme that's going to be carried through. The Act 2, there's this point of tension. This is the inciting incident that then takes you onto this his adventure, and then there's some kind of climax and a resolution. And the way that we would think about it is in the scientific paper, where we have got an introduction and we set out the context, the background context that we're working in. And we say, but there's a problem. The reason I'm writing this paper is because there's a problem. We don't know this. And then we talk about a new site or a new piece of equipment or some new data that runs us through. That's our results, our methods and our results. And then we say, right, what does that mean? And more importantly, what does that mean for the future? Where are we going next? What other things need to be done? So we kind of do a 3-act structure format, really. I think the important bit, really, is thinking that we need to really highlight these points of tension that really drive forward the narrative, because that's the key driver. Up to the right is to remind me to say that if we're writing a research proposal, we absolutely use this. You know, there is this really big problem. We're trying to decarbonize whatever, and lots of people have been working on it, but we can't do this. I have a new method. I have a new technique. And with that method, what I'm going to do is I'm going to go and do this. I'm going to collect some samples. I'm going to run this kind of a set of tests and experiments. And that's going to give me this. And I think we're going to produce that. And if we have that, we will be able to do this and this and this and this. Give me the money. That's what we do. That's what our research proposal is. And if you can write it like that, around that table of reviewers, where maybe one of the 20 people around the table actually understands the science of the topic, but everyone has the same vote. There's 19 other people going, I like that one. I don't know why, I just liked it. I think I understood it. So in other words, the narrative format just makes people access those things much, much, much easier. But if you really want to do storytelling, you have to watch South Park. Now, I have to usually tell people that South Park is very, very rude and has to be watched with caution. But the South Park is probably the best exponent of something called the ABT method. And that's the and, but, therefore method. And it's essentially a 3-act structure. In fact, I often do, when doing workshops where people it's 3 sentences. What's great is the idea of the elevator pitch, where you've got a really short time to do it. You basically have the setup, which is da-da-da-da-da and da-da-da-da. But that's your inciting moment, that's your tension. But there's this problem. Therefore, therefore is the resolution. Therefore, da-da-da-da. And it works a treat. It really is such a simple method to do. But it's a 3-act structure. It's a beginning, a middle, and an end. You've told a story, and usually someone can do it in 30 seconds or a minute. And you can repeat it again. So it's a very useful kind of tool. This is one that Nancy Duarte started, was one of the ones that started TED Talks. And she does a TED Talk about TED Talks. But this is what she's called a sparkline theory, where she analyzes lots and lots of speeches. So Obama's inauguration speech, JF Kennedy's kind of speech, Martin Luther King's speeches, and tries to kind of capture the essence of them. And she says, like, this is what, the beginning is what is. Painting a picture of the reality of the world so that when we start, whatever that starting setup is, it's a very familiar world to you sitting in the audience. You think, oh yeah, I recognize that. But there's this inciting point. Suddenly you're off. You're taken to a strange place. It's a bit alien. You think, whoa, what's just going on? And you're talking about what could be. But you've only taken some of the audience with you. You need to drop back into the what is. Some of that audience is still thinking and processing. It really is probably too expensive. You're probably thinking it's too expensive, but actually we know the costs have dropped back into the what could be. So you do this thing where you drop into the what is, and you took sort of what could be, and you go back and forth. And in that case, what's a TED Talk, 15 minutes, 60 minutes, 17 minutes. So the key bit is at the end, where you have another point that takes you out into this call for action so that you're energized. That's kind of like the agency part in the Eden Project one, where you leave full of beans wanting to do something as a result of this talk. So I think these methods are quite good. But what's quite interesting, they're about transformation. Stories are about transformation. If there's no transformation, it's not really a story. And so when we think about transformation, well, these things called S and X curves. S curve is this innovation curve. It starts off slow, picks up pace, and then it's established, and that's it, really. And X curve is a kind of version on this, which I'll explain. So a very famous one about transformation is this one here, which is is when basically the petrol engine comes in for the motor car. And so 1900 on the left, 1915, so in 15 years. So in the one on the left, it's a case of spot the car because those are all horse-drawn carriages. I think there's one car tucked in there. The Model T Ford isn't yet been mass-produced. And then by 1915, it's spot the horse. There's really none. They're all cars. So these things happen really fast. And so that is the X-curve. So you've got automobiles. Yes, that's right, yes. It's like I thought I got the wrong way around it. You get automobiles started to pick up, and now over time, the number of horses that are used goes down, and there's a crossover point, and suddenly automobiles are the standard way, and horses are consigned to kind of history. If you want a more recent example, this is one about new car sales in Norway in the last couple of decades, and you can see that what we see is the diesel, petrol declining and declining and declining, flatlining off, and you can see the rise of the electric vehicles. And you get them. There are all sorts of innovations comes in. There's a new kid on the block in terms of technology that picks up, rapidly rises and becomes established. And at the same time, the conventional one goes more and more diminished. And so you get these things where, if we're trying to look at transformations, a kind of set of stories really about, so for example, we start here, the experimentation, which then gets picked up, the change accelerates, and then it emerges, people start to recognize it and be talking about it, and then before very soon becomes institutionalized, and then it is the standard, whatever it is we're talking about. And meanwhile, of course, the system it's competing with has the opposite effect. It's been optimized up the top there, and then it starts to be destabilized, chaos, breakdown, phased out. So we might look at this for, I don't know, I mean, the university sector we're thinking about at the moment kind of feels like that. It could be people, there's a lot of talk about the identities crisis in geoscience, about the recruitment, etc. There's lots of ways about thinking about it. But the main thing that I want to emphasize is that there's a story to these changes that you can put a storyline on. So this is Nancy Duarte again. She's got this thing called the Venturescape. And she says, look, you have this thing where there's a start to it, and there's a story around it starting. And then that acceleration, that growth phase is another kind of set of stories. And then that, as it gets maturity, becomes successful and standard is there. But interestingly enough, when you get to here, of course, that's the end of the road. There's another thing sitting in the wings, in the shadows, that's about to come out and knock you off your perch. So the thing is, you have to jump from here to here onto this next one in order to survive, whether you're an individual or a company or an organization or whatever. That's what you need to do, constantly be evolving to take the next thing that's going to sweep through. And she's got this whole thing about the way to storify this, narratives for each of the bit, about what she calls the leap. So you're in a nice, comfortable place. Suddenly the world around you is changing. You kind of sense it's changing. You feel uncomfortable because you like the world that you've co-evolved into, but you also know that you're going to have to do something. And at some point, you leap to this new thing. So I've been interested in this for a while, in various ways. And there's a thing that Oxfam, particularly Oxfam, developed called the 3 horizons, which is kind of the same thing. There's 3 curves, 3 future horizons. So this one is the dominance of thinking, and this isn't right. This is today, right now. And so the point is that one of the ways of thinking is called business as usual. So it's the kind of thing we do all the time. It's the standard thing. Whatever your job is, when you go into work, that's what business as usual is. So you're aware there's things that the status quo, but you're also aware that the world outside is changing, and you think that it's not fit for purpose. There's going to be problems ahead. There's also in the wings this visionary, radical things, which seem too radical and visionary to actually embrace. But you kind of look at them and think, actually, that seems to be gaining a little bit of pace. If that comes through, that's going to change the world. And then the middle one is an entrepreneurial space, an innovation space that says, look, I'm not going to jump, I'm not going to leap all the way to the visionary, but actually, I'm going to do something in the middle. I'm going to do this, I'm going to tweak this, I'm going to change this, I'm going to try to adjust. And the point is that every one of us has all 3 of these, and every company, every organization. The bulk of the activity is Horizon 1. We then have a little bit of, sometimes we go, hey, I've got a crazy thought. What? And you ask, crazy. And then what you do is you often have a thought, well, I tell you what I'll do this, and I'll bring this in. The problem is that if we track it over time, the business as usual, if it's true, if it's a paradigm change, it's got to be fit for purpose, gradually it will decline. What it will try to do to sustain itself is grab some of these innovations to keep itself artificially going for a little bit of time. But ultimately, if this is the real future that comes through, it's not enough. And neither is the entrepreneurial one, because the entrepreneur was set up not to address the root causes. It's an adjustment. So it never can actually deliver the full thing. And I'll explain what I mean by that, because we did it for the earth sciences. And this was just a mental exercise. In fact, I think in the paper we say, look, we've done this, but go away and do your own. Map it out, what you think it should be. So what we said was, what's H1? Well, for geoscience departments, there's a sense that we're completely coupled with the idea of economic growth. So our job as geoscientists is to supply stuff to the economy to keep lives and livelihoods going. What else? So very strong alignment with the extractive sector, so mining and oil and gas. A very traditional core curriculum, so I studied in the 80s, the core curriculum in the 90s pretty much the same, 2000s pretty much the same. In fact, actually, I think we felt a responsibility to keep it the same, We must keep teaching crystallography, we must keep teaching metamorphic geology, we must keep whatever it was. So I focused on technical training, very much integrated with maths, physical sciences. We've got some applied stuff, but it's really around things like hazards. And so that's the business as usual. So what might H2 be? Well, H2 could be this stuff around the energy transition. So we're talking about, we know we're going to need to decarbonize and move to low carbon. So it'll be things like, well, energy transition is a driver, so new technologies. We have a geoscience for society, make it more explicit that we're trying to help society. So things around geoenergy, renewables, geothermals, critical minerals, carbon sequestration, et cetera, et cetera. And we focus on advocacy and integration with business. Anyway, the point is we get so far, and then we might get to here, but actually, the point is that what we're obviously getting to is a low carbon future. It's not the full deal. It's not delivering on that human well-being thing. It's just getting it to part of the way. And so we said, oops, what would a safe and just operating space for humanity? And this is this one where it was just plucking things that were coming out. So long-term sustainability is now the driver. It's focused on people skills. There's this thing about there's a planetary well-being, but there's also a human well-being side. There's more of the priority around health and water, for example. There's stuff about decolonization, about trying to look at that, nature positive, bring in the social sciences, humanities, creative arts much more strongly in. Geoethics, been much higher profile. Looking at local sustainability, sustainable development, and transdisciplinary partnership with a whole multiplicity of different stakeholder groups. So the point is that's not what the future is going to be. It's a way of mapping out. And in mapping it, you start to ask yourself questions and you start to just change your kind of positionality. So I did another ChatGPT because it bugged me. It really bugged me. So I kind of said, I can't remember, I think I said the University of Plymouth geologist and blah, blah, blah. And then now that apparently looks like me. So anyway, so just to bring you back to this, because I think this is a nice template for these narratives. We absolutely have something to do with the ultimate means, the planetary well-being. A lot of what we fundamentally do is about understanding the rhythms, the thresholds, the sensitivities of the planet Earth system. And that's really important. So that's about saying that trust us as geoscientists. We understand their system. If you're worried about our system, trust a geologist, a geoscientist to do that. But we also have a responsibility in the economy. The economy, people need prosperity, we need to do things. So we need to work with industry, with companies to make them more resource efficient, et cetera, for new materials, et cetera, driving that. And I think we do both of those relatively well. They're fairly commonplace elements within geoscience departments. But the interesting one, I think, for me is what about the top one, about the people one, about this idea of delivering on human well-being and things about including this sense of community, sense of belonging, and all the rest of it. That's the one I think we need to look at. And so that's why I wanted to finish on this, which is geoheritage, which is kind of, I mean, it's not on that original plot. Very few, if any, geology departments teach it. But actually, one of the revelations, but I've been 4 years in in Jordan is that a basic knowledge of landscape and geological history can transform communities by getting them to understand the scientific template that they're in and the way for them to exploit it for ecotourism, sustainable tourism, or whatever. So in this way, you can actually take very basic geology. It's not rocket science geology, and actually really empower communities to kind of produce for themselves. And I think that I like this quote, really trying to talk about this way of this connection, really, but the challenge of our time is that people feel disconnected and insensitive to these huge, huge problems. And this is this gap. So the question is, how can we cross that gap? How can we translate knowledge into action, change behavior, and embody knowledge with that sense of responsibility and commitment? And part of it is by not just having our knowledge, but actually bringing in multiple sense of knowledge, the knowledge of other communities that people actually live there. So I think that this notion of storytelling is a really important bit, because everyone can tell stories, everyone has stories. Geologists just have a better set of stories, and that's one of the things we need to convey. Thank you very much.
Great, thank you. I'm sure lots of you have got lots of stories that you want to share with Ian, but before we get to
You
that
have to
point,
pitch an ABT.
good challenge for everyone. So we're going to open the floor to questions. So for those of you in the room, please put your hand up. We've got a couple of people with some microphones that are going to come round. Please wait until you've got the mic so the people online can hear the question, and then Ian will be able to answer it. And for those of you online, you're able to add your questions into your webinar window, and somebody in the room will read it out for you so that Ian can hear it and then hopefully respond. So would anyone like to get us started?
Silence.
We've got a couple down here. So first one here, and then second.
Just thinking of your illustration of a library, many people love puzzles and detective stories. Do you feel we sufficiently understand the puzzle that is the Earth? May there be other puzzles lurking unseen at the moment?
Oh, I'm sure there are. I mean, I think one of the issues, we often talk about it, don't we? The geologist is the detective. They come along, but the crime scene happened 200 million years ago. We use that analogy, that metaphor quite often. I think there are. I think the point that I would maybe draw out of that one is that's a really useful. So I think one of the general ones is we need to find multiple narratives. There's a whole host of them at work. The detective story one is a really interesting one. So I would say in that one of the things will be to really understand what a good detective story is. And then when we're trying to build it, because we use it quite loosely, we say, oh, it's like a detective story. But I think actually trying to think about how are we like detectives? People love detective stories, you know? So I think that we use it as a narrative. I think in terms of the mysteries of the Earth, I mean, there's tons. I mean, we mentioned that was partly the motivation with David Stevenson, things about, you know, his kind of tongue-in-cheek thing about the probe into the center of the Earth is the mysteries are all down there. Yes, there are mysteries up there, but they're kind of not irrelevant to us, but they're so far out of our normal everyday that we're not really touches. But actually, some of the mysteries down there might have an absolutely direct effect on our lives. So I think there's plenty. Have you got something in mind that you're thinking about? I thought you might.
There are also mysteries to be seen
on the. Thank you. There are also mysteries to be seen on the surface of the planet.
Uh-oh.
And they are very illuminating. And I would love to discuss them with you. It's not
all right
appropriate for this situation.
Find a pub.
But a bit of a challenge. Thank you.
And just here as well.
Thank you. I think everybody that's above university age will probably agree with what you're saying in terms of the transformation of the sharing our message and the impact of the message. But we've got a load of young people going through schools, colleges, and universities that are still being fed and challenged and assessed on that classical curriculum. How do we get the powers that be in universities and colleges to be adventurous in testing and getting those technical minds to be able to share that message for a popular audience?
Yeah, I mean, it's tricky. I mean, I think the best teachers, I know loads of earth science geology teachers are amazing, and they find ways around that by connecting stories to the local areas and taking people out and their own experiences, and they tell stories. they know that. I think the problem is probably this notion that we have that there's a curriculum that is sacrosanct. To be a geologist, you need this and this and this and this and this. And therefore, to go into geology, you need this and this and this. And the whole world is completely turning makluba, as we say, in the, it's upside down. Just look at AI. Or there's a whole bunch of areas of cutting edge of science that are the quantum world. There's things that just blow your head. And so those worlds are changing really fast, and you get a sense that geology is not changing. And yet those of us in it would say, well, it is. And we haven't managed to get that across. I think the universities are probably that transition ground to do this. But actually in universities, we struggle with this as well, because there's an expectation of that out in industry, they need certain things, and therefore they'll want some, we want field work, we want the microscope work, they want this and this and this, technical skills. And industry themselves are reeling because they're changing and they're not sure, if you go into the energy industry these days, you can be doing wind farms and solar as much as you can do. The whole system from schools all the way through is changing. So I think that this is why I think the narrative is quite good, because I'm not saying there is this story or that story or that. It's about finding the story. And I think each individual, whether it's an academic, the way they sell their course to students come in, the way the teachers sell to coming into the sixth form, for example, to do A-level. It's thinking these narratives. What is the narrative for that audience? What makes them tick? And that's what to do. That's why I think the phone is the wrong one, because it suddenly, as I say, that audience doesn't care about the phone. It might be we want them to care, but they don't. So that's a wrong narrative for that. But what's the right narrative for that set of people? It could be, for example, getting dead excited at AI. It's like, you say, well, actually, in AI, we can do whatever. But it's a problem, a thorny issue that, well, you guys are looking at this as well, the education section here, the committee, trying to think about what the messaging is. So I don't know the answer.
The idea of the phone is a good one. We have a good poster here: minerals in a smartphone, minerals in an electric car, minerals in a solar panel. Maybe we need minerals in a toaster.
Toaster, yeah. Well, we put at Plymouth, it's when you were there, Arjun, a colleague of mine, put a smartphone into a mixer, smashed it to bits, and then dissolved it into powder, or put it into powder, and then put it through the mass spectrum. Anyway, you got the full and the SEM, and he worked out what it was, and there's a nice little video on it. But people still don't care what's in it. So I mean, somewhere.
We had another question down the front here, but whilst we get the microphone down here, I think we'll go to one online that Alicia has.
So someone online has asked, how can you develop a story based on the fact that allows for uncertainty yet is persuasive? I am thinking of an audience that does not think that scientific evidence is true, believing that science has not just caught up with what they feel to be true.
Yeah. So I think this goes to the heart of this business about we're not really in the truth game. We're not trying to sell truth, because if we're thinking into the future, we don't know what it's going to be. So really, rather than us, sorry, we've been sucked into this idea of probability, that this is most likely to be true, and then trying to sell the most probable. What stories create is they create plausible futures. And those plausible futures open up space for people to have conversations. And that's the thing where there's lots and lots of times where people, don't believe in science, particularly around climate, for example, climate science, I'm thinking. And we hit them with facts, and we try and tell them this is what it is. And actually, I think the much better approach is opening up spaces for conversations, because people don't understand the science. It's full of scientists that are mentally unusual as well, as I said before. There's lots of things that get in the way, lots of baggage. So creating space, stories create space for conversations. And I think we shouldn't be too dogmatic to say, this is what, I read a paper, this is what it is. Because, how many times have we been wrong in the past? So I think it's about a genuine conversation that we would start to have. That's the way I would talk about it.
We had one just here.
Thank you very much. That was really interesting. Spent most of my career as a government geologist advising ministers, and I can really echo what you're saying about
Good.
storytelling.
I was terrified there. I was ready to,
No.
I was ready to go off and I couldn't. It works there too.
I mean, I found very early on that the vast majority of government ministers, as the vast majority of the general public, don't understand what science is. They don't think scientifically, and trying to talk to them as a scientist is a complete waste of time. So the idea of storytelling is the only thing that really works.
Yeah.
And I've been shocked in various points in my career by the sheer lack of understanding of Earth processes. I think probably the most frightening one was a cabinet minister. We were talking about water resources, and he seriously said, well, why don't we just put a pipe from Northumberland down to London and it all run down to London? I mean, that's the sort of level we're dealing with. So we had to tell the stories that will then
I think so. And this is why I think the problem's ours, actually. I mean, so in that case, there's ignorance in the sense of not knowing there. But I think we've not done our job about making those connections. We've assumed that if we just tell them stuff, it all feeds in. And so if you think about it, the politician is an interesting one, and you know this, that every day people are trying to sell them ideas to come. And particularly when you get scientists, and if they're not got a science background, they feel very defensive about this clever class, this boffin is going to come in and try and tell me stuff. And he's going to tell me what I should do. And then that boffin leaves, another one comes in and tells me something completely different. No, I never understood him, but I'll just tune it out.
Yeah.
And I think that ability of ourselves just to take that stuff that we know, our knowledge base, and turn it into an engaging story, punches through all of that kind of straight away. But we don't, I don't know what if it's that we feel that's us, dumbing it down, or because we're there as a specialist, we have to be super clever and doing, I don't know what it is. But I think that we can, as I said right at the start, I think we're genuinely authentic storytellers, the way we talk about the planet, and just making that the way we communicate should be
Absolutely.
first and foremost. Yeah.
Okay.
Thank you.
Okay, I didn't see any more hands in the room, but I think we have one more that we can do from online. So Alicia, over to you.
I was going to say one last simple one, but perhaps not. I'm so sorry. Do we need to adapt our storytelling technique for the current TikTok generation?
I don't know. So I am not of the TikTok generation, and I haven't made TikTok. Maybe we should have Hayden Moore somewhere to talk about it. I think storytelling is storytelling. So when I was making programs, it would be a 1-hour documentary, and that's a particular format. But what's interesting is seeing Nancy Duarte's thing for a 15-minute TED Talk, or the ABT for the South Park crew being 3 or 4 minutes for a little section. I think there's just a basic ways of telling stories. And so I think that we need to understand those basic rules and then start to explore them ourselves, really. And so I think TikTok videos, and I'm sure if there was a media kind of on there, they would analyze that and be showing how you are telling stories on TikTok and in the same kind of format. So I think that almost all communication, maybe even visual storytelling, things like that. Where's songstress? Where is she? You sing songs about geology? Is stories part of those songs?
They are. I guess the story about Earth.
Yeah. So I think stories just work across the board, really. That's
And a really good note to finish on. So I hope you'll all join me in saying thank you to Ian again.
Thank you very much.
So before we let you all go, I just want to let you know that our next public lecture is on the 17th of June from another fantastic storyteller, Dr. Heather Hanley, who's talking about Forged by Fire, how volcanoes shape our landscape, law and lives. someone that Ian knows very well and will testament that she tells a really great story. So that would be a really good one. So please sign up for that one. And we also are in a very unusual position today that our public lecturer for October is currently in the audience today. And Charlotte, who's over here, is representative from KSAT, and you might notice us in front of a banner here. So KSAT are our sponsor for the public lecture series this year. So we wouldn't be able to put on these public lectures in the way that we do without their support. So huge thank you to KSAT and to Charlotte, who will be giving a talk later in the year. And thank you very much for you all coming today. Those of you in the online room, thank you very much. We hope to see you next month. For those of you that are here in Burlington House, we're going to open the doors at the back of the lecture theatre, and we hope you'll all join us for a drink in our lower library, and you'll be able to chat to Ian a little bit more over something cold. So thank you very much.
Oh, that's, oh, yeah.